Hello everyone, I welcome you to my research presentation. My name is Tanmoy and I am going to present on Enhancing Education Policy Estimation, a novel-rich fuzzy regression approach for handling multicollinearity with fuzzy input data. I finished this research alongside my co-author Dr. Hemlata Joshi, and this research primarily focuses on regression modeling in the presence of interdependencies in the independent variables in a fuzzy scenario. So for the basic introduction, whenever you're trying to fit a regression model or whenever you're trying to look at a linear associationship between a set of independent variables and a dependent variable, we fit our classical regression model, that is y is equal to x beta plus epsilon. And with the method of ordinary least square estimation, we find the estimate of beta as x transpose x whole inverse x transpose y, which is an unbiased estimator of beta. But what happens in many scenarios is that whenever there is a dependency or there is an amount of correlation present in the independent variables, that introduces us to the scenario of multicollinearity, and we fail to find this unbiased estimator of beta. In these scenarios, we take help of the ridge regression method, where we add a positive constant k to this hat matrix x transpose x, which reduces the variance of this estimator significantly by taking a certain amount of more bias in the estimator. So this gives us better results than the ordinary least square estimates. So this is the scenario of classical relationships and between x and y and classical regression models. But in many scenarios, we find different type of behavior in the data, which is named as linguistic data or data with human ambiguity mixed. That is, we can take an example of the temperature, we can take an example of the words like young, tall, or high. You can feel that these attributes do not specify any number to them. They can be different from person to person. That's why the ambiguity is mixed inside them. And in the right corner of the slide, you can see a particular representation of fuzzy data, where you can see the y is a certain amount numbers alongside with spread that gives us the fuzziness in the number, which is then whenever you're trying to incorporate a regression model in these scenarios, instead of classical regression model, we take the fuzzy regression model, and the equation or the regression model is then shown in the or inside the orange box. So analogous to classical linear regression model, multicollinearity can also be an issue in this scenario. So to deal with that, we will see what kind of methodologies that we can apply. Our research primarily delves into these two situations, that one is with the presence of multicollinearity and another is the fuzziness in the data, that we are not dealing with classical data, that we are looking at a complex relationship between y and x, where human ambiguity is mixed. So, at the years of 1965, 1968, and 75, the author Zadeh, he introduced us to the fuzzy sets, and he introduced how we can apply certain probability measures into fuzzy events, how we can represent a fuzzy number, and how the concept of linguistic variable can be applied in the mathematical scenarios, or how can statistical methodologies can be applied. This kind of shedding of light was happened in these years by this author, and with the advent of time and the years of 2019 and 2020, these three Korean authors, they have introduced a method in their research called alpha level estimation method, which takes the concept of multicollinearity in the fuzzy scenario, and they try to build a good model so that we can get the least coefficient or the unbiased estimator for these fuzzy coefficients in this fuzzy regression model. But the lack of delving into a large amount of applications or complexity of relationship between x and y, but we yet found, which was not there, so that gives us enough amount of space to take into different complex domains for this kind of applications, and to see how these models can be fit there. The objective of this research would be to deal with a particular application, that is the education policy, where we'll try to develop a model to depict the GPA as a fuzzy output in the presence of multicollinearity in the independent variables. And the primary objective would be to find or fit a particular rich regression model alongside the fuzzy scenario. There is a fuzzy regression model with a fuzzy output, and independent variables can be crisp, but there should be presence of multicollinearity in them. We'll try to fit a regression model on that. And the secondary objective would be to check the performance of this model and to compare with the previously available classical fuzzy regression models, that is the counterpart of it, and to see how the model works better from the previously available models. So the main methodology would be something like that. We will try to first identify how we can represent the fuzzy numbers. The primary representations that are available can be in two ways. One is the membership function representation, and another one is alpha level set representation. In the membership function representation, we have the set fuzzy set as the crisp input alongside a membership function. Membership function holds the degree of association of a crisp number x, which makes it fuzzy basically. And another presentation is the alpha level set representation, where we held the support of the fuzzy set at a particular level alpha, which where the alpha can take any values between 0 to 1, which gives us a particular representation of the membership function or the fuzzy number in a trapezoidal shape or a triangular shape with the left hinge and right hinge, and as you can denote it L and R, and mode at x, or basically n. The mode of x can be found at n. So the main objective here is to be estimate the fuzzy regression coefficient of the fuzzy regression model by reducing these two modified ridge logs function with the help of alpha level algorithm that we're going to see further. So these are my two objective functions that we're going to reduce to find the optimal value of the fuzzy coefficient for both left and right hinge. Okay, so to do that, first we'll set an alpha level for the fuzzy coefficient, where our alpha will take the values from 0 to 1. And for each of these values, the loss function will be calculated, and with the help of minimax principles, we'll find the best coefficient that will give us the least value. After we find the least values for these alpha level sets, for a particular level of alpha, we'll get the least values, and then we'll try to find the membership function by regressing this left and right hinge coefficients, and with a particular constant that the membership function at the left hinge and the right hinge at the level 1 would be 1. So that's how we'll get the regressed or the predicted set of y with its spread. Then for both the left and right and middle scenario, then we can apply various performance metrics. Particularly we have taken the Raman distance here in this case, and the RMSE or mean absolute percentage error. These two performance metrics can be taken to find out the performances, and that is done in our research also. And for the final part, the optimal value of the tuning parameter k. So there are various methods available to find the optimal parameter k. One of the latest methods that we have taken here is the cross validation method. We find find with the help of cross validation the value of the parameter k, and we then fit it into the objective function, and for each of the alpha levels we find the regression coefficient, and we see for the help of the minimax principle which is the least, and then we regress and find the membership function and the regress set. So in the application part, a survey of 25 students from a prestigious university was conducted, and their GPAs or their overall performances was taken as the dependent variable of y, which had the fuzziness mixed in that. And with the help of the independent variables, which were like SAT score, the student's SAT score, the high school GPA of the student, or the amount of hours he or she particularly takes in an hour to study, and their current family income as the independent variables, they were crisp. So this in the right you can see the data set. So among these independent variables, we have found a high condition number, which gives the clear indication of multicollinearity present in the data, which gives us the purpose to fit a rich fuzzy regression model in this scenario. So by applying this alpha level estimation method that I discussed earlier, we can see that coefficients, the estimated coefficients are in front of us in the left side of the slide. So by looking at this number, the numbers are like the OLS estimates and the ridge estimates, but by just looking at the numbers, we cannot figure out much about the data. So it is better to look at the visual representation, which you can see at the right end of the slide, that the black triangles are the actual data points as the fuzzy numbers, triangular data points, and the reds are ones with the estimated ones. So and also at the top you can see the VIF values for the independent variables, the various inflation factors values. All are greater than 5, some are greater than 10 also, which serves as a clear indication of multicollinearity present in the x variables. And overall the performance, you can see at the left bottom of the slide, that the rich fuzzy regression performed well both in terms of RMSE and in terms of mean absolute percentage error also. As you can see, there's a significantly less number than the multiple fuzzy regression when in the rich scenario. So In a nutshell, this investigation opens doors for schools, educational bodies, and online learning platforms to create better education policies tailored to students' needs. The study highlights the effectiveness of the rich fuzzy regression model, especially in dealing with complex data situations. It's a game changer, showing how we can handle language-based data fuzziness using solid statistical methods. The research not only benefits the education sector but also hints at the untapped potential of fuzzy regression models in solving real-world problems where ambiguity is the name of the game. In sum, it's a significant step forward in understanding and applying these models, especially in the crucial area of education policy, with implications reaching far beyond the study itself. So that will be all from my side. Thank you.